let's take a look at our student work here. Let's look at the first one. Alright, in this problem here, I recognize that the student knows that it is factored form. They wrote the formula right below it. They identified all their letters. Let's see if they got it. X is equal to a, I don't know what that says. Does that look like a +1 class? Yeah. Let's circle that. It should be a -1. And then x equals, what does that say? X is supposed to equal +5. Remember, in the formula, it has the minus sign, so you kind of both ignore the negatives right there. Do you see that? This one should have been changed to an x minus -1, and then you can see p equals -1. A opens up, yes, but -1, so again, if it helps, draw a graph for every problem. X equals -1 is over here, and x equals 5 is over here, and my graph will look like this. So the answer is no. It doesn't match. Although the graphs do match that they open up, the graph has 0 x-intercepts. Do you see that? Or if they were going to cross in the positives. This one has 1 positive, 1 negative. Let's look at function number 2. This student recognized that it's positive. That's correct. They wrote the formula right above it. That's good. H value should be -6. Does that say -6, class? It looks like it to me. And then K value should be -5. Ooh. So the order pair should be -6, -5. If you graph that, -6, -5 is in quadrant 1, 2, 3. The graph is opening up, but it doesn't match, so the answer is no. So no is correct, but I see the mistake that student wrote here for the K value. You can write the vertex is in the wrong quadrant, right? In our picture, the quadrant is in quadrant 1. Question number 3. No parentheses, standard form, correct. Wrote the formula below it, correct. A value is, okay, so remember your A value is a number. What does it cost? So this student should not have x squared. You shouldn't have an x. B is -400, and C is 10,000. So it does open up, correct. My C value is in 10,000. Now, the student doesn't have an explanation. Now, if you look at the parent graph, you'll notice that it'll eventually hit 10,000 up here as a y-intercept. So this student has it. Now, this student can adjust their graph to go above the x-axis. So the answer is yes, it can match. This student doesn't have an explanation, so I think it says that on the previous page, right? Describe or explain. That's using words. So yes, opens up, and y-intercept matches the parent. So that was for question number 3. Question number 4. Got it? Alright. I'm not sure what that looks like. But I have this. A is 3, correct. P should be a negative. Q value should be negative. You see your foldable? There are two ways to know that this is negative, okay? First way is what my way is to change these into two negatives. Raise your hand if you like doing that. Okay? Okay, let's say you don't like that. You can use your foldable and go towards the factored form. P and Q are the opposite sign in the equation. So this is the second way. Opposite of positive 1 is? Negative 1. Opposite of positive 5? Negative 5. Let's graph it really quickly. Crosses at negative 1, negative 5. Opens up. Classes that match our graph? No. Red light, no. Why does it not match? Although it opens up, no. Matches parent in concavity. Okay, this is a fancy word. Concavity basically means opens up. Okay? But you can also say the vertex. That's a good way of thinking about it. The vertex is in quadrant 3 here, and ours over here is in quadrant 1. Okay, but vertex in wrong quadrant. Remember, over the years, the number one mistake in this problem is saying stuff like, it's negative. It's too broad. I don't know what you're talking about. Do you have a negative attitude about math? I don't know why you mean saying negative. You have to be very explicit. So try to use those academic words. Moving on, function number 5. Vertex form. A is positive 2. New opens up. H value is 6. K value is, should be a positive 5. 6 comma 5. So if we graph ours, write 6 up 5, opens up. The answer is yes, because vertex equals a smile. Okay, remember, let's make sure we're on the same page. This is why we're doing this. Vertex is like your skateboard ramp. It's the lowest point. It's the half pipe, right? Right here. Do you see it? That's what the vertex is. So when the student's saying the vertex, we should have written like the vertex is in the correct quadrant. Let's write that. Yes, because the vertex in the right quadrant. And it opens up. Does that make sense? And last question. Uh-oh. I got a missing. How about this one? Opens up, correct. Standard form, they have the formula. Let's draw a picture. Let's see. No, it cannot match the graph because the vertex is negative. Okay. Standard form doesn't tell us about the vertex. We would have to use a pretty complicated formula. Looking at your formula sheet, in standard form, this is how complicated it is. You would have to take x equals negative b over 2a, whatever you get as your answer, put it in for the into the function, and then you would get the vertex. Pretty complicated, right? So standard form doesn't tell us about the vertex. It tells us about, the only thing that should be highlighted on this page is the y-intercept. The c value. So if we have a c value that's negative 5, this is where our y-intercept is. You see it? And if I graph this, something like this, does that look like a graph? So when I'm going to grade this on your quiz next week, I would give partial credit for no. I would give partial credit for all of that stuff. No cannot match. This part is incorrect. So you can say something like the parent graph, no, that's right. Parent graph has a positive, class, what is this point called? What is that called?
Y-intercept.
Has a positive y-intercept, but f, the sixth function, has a negative y-intercept. Zoom in for you. Everyone say, don't abbreviate. On your notes, you can abbreviate, but on your quiz and test, don't abbreviate. The students arguing with me, Mr. Ring, I wrote this. I said, I don't understand what that means. What does GD stand for?